I'm going to produce several videos here to explain this chart. This is the history of encryption techniques, or I should say of privacy for Wi-Fi. Now, one thing I don't have on here is just an open Wi-Fi system. So in other words, one that's totally unprotected. You just walk into a room, you pull up your phone or your laptop and say, I want to connect to this to XYZ network, and it doesn't ask for a password. That's just an open system, and it has no security whatsoever. But the first attempt at security was something called WEP, or Wired Equivalent Privacy. Now, it's kind of a misnomer because it really wasn't very private. Sometimes we call it the worst ever privacy. We can crack WEP now in about 5 minutes, sometimes even as low as 3 minutes if we are experienced at it. 1997. It used an encryption scheme, an algorithm, a formula called RC4. And in order to give it a key, we had what we called a shared key and an IV, or initialization vector. Now, the shared key was a set of characters, usually a number, I don't remember, I think it might have had some letters in it, that you would get off of the Wi-Fi device when you set it up. You didn't tell it what you wanted, it told you what it is. So we call that a shared key. Now, here's the way that it worked. First of all, it was a stream cipher, shared key authentication, and it looked something like this. Here's the sender. Let's say that this is your computer. And by the way, the word goofy here is, let's just pretend that that is the set of characters that the wireless access point or the wireless router gave you. You didn't put that in. It wouldn't be something so obvious. It would be a set of unintelligible characters, but let's just pretend now. This number over here is what we call the IV. Now, in order to send a message or to authenticate to the wireless router, either one, you had to send that shared key. So how did we send the shared key? Well, we attached to it a pseudo-random number, IV number, along with an encrypted version of the shared key. So it looked like this. First, I'm going to encrypt the word goofy here with the RC4 encryption scheme, and then I'm going to attach the initialization vector to it and just concatenate them. I'm just going to stick them together here and send that across the wire. Now, this looks secure at first glance. After all, I have encrypted my key, the word goofy, and so nobody should be able to tell what that is. And by the way, the next frame will have a different IV and so on. Now, notice here that what is sent across here is the encrypted key, but it is the plain text IV. This was not encrypted, it was not changed. It was sent right across the wire as it is. Here's the 1745825, 1745825. And then the encrypted key here called goofy. And then this, of course, would be used to decrypt the message on the other side by the wireless router. Here is the problem. This number, the IV, is small and it's pseudo-random, which means it's not a true random number, which means there are going to be patterns. Eventually it's got to repeat itself. And we can mathematically figure out this word goofy if we simply look at enough of these and do some math to it. We're not going to go into how the math is done. It's pretty complex. But we can derive this pretty quickly. We only need a few tens of thousands, probably about 30,000 to 50,000 frames sent, which is not hard to get, by the way, if you're if you have traffic going across or you're generating traffic, it only takes 3, 4, 5 minutes for that to happen. So you get about 10,000 of these things. You plug this into the cracker, and it tells you, oh, the keyword is Goofy, and then you can put Goofy in another computer, and there you are. You have cracked this this network. So you can see that it's not very good. And so we needed a fix. This happened around the 2003 time frame, and we needed a fix, and so we were going to go to WPA, which we'll take up in another video.